Algebra 2, Lesson 2, Evaluating Expressions and Combining Like Terms. This is really kind of my favorite time of year to be a teacher. You know why? Because this is all review. I'm not looking at a bunch of like blank faces where everybody's like super confused even whenever we get to the title, because most of us know how to combine like terms, correct? We've done this before. We're here in Algebra 2. An algebraic expression is less complicated than the name sounds. It's an expression it might contain letters that represent unspecified numbers. Those letters are called what? If I've got an expression or an equation that has letters in it, what are those letters called? Variables, right? We see that right there. So in a real simple algebraic expression, you might see something like x plus 4, where I don't know what the value of x is when I write it. Okay, and I don't have enough information there to answer x equals yet, do I? All I know I'm saying is just x plus 4. But that expression depends upon the number you use as a replacement for x. Say I'm going to plug in negative 28 for x. Now I can solve the equation. Or if I said x plus 4 equals 12, I could solve 4x. Right? Is that pretty well familiar with everybody that's in here? Right? You've done this stuff before. So if I plugged in negative, say, 32 for x, right, I'm going to actually substitute it in for x. Negative 32 plus 4, my equation would equal negative 28. Right? If I plugged in and I said x plus 4 equals 12, I would subtract 4 from the left-hand side. I'd subtract it from both sides. I would know that x by itself equals 8. Correct? We can bobblehead it up and down. Yeah, I get that. That makes sense. Okay, we know what variables are. Let's see if we can move on to the next slide. Computer's going to think about it. There we go. When you replace variables in an expression with selected numbers and simplify using the order of operations, that is what it means to have evaluated the expression. So you'll see things like in your book or on a test where it says evaluate the expression. Basically what that means is to simplify it or even solve it. But they use the phrase evaluate the expression. This should be redundant, not necessarily redundant, but old information. How many of you know the order of operations by raise of hands? Every hand went up, except those people that were still writing things down. Okay, everybody's hands are up. I've heard people use all kind of different mnemonics for this. How many of you use like PEMDAS? PEMDAS? P-E-M-D-A-S? Anybody use GEMS? GEMS stands for grouping symbols, exponents, and then M for multiplication division, and then S for subtraction addition. Never heard of that one, that's fine. Which one do you use? This one, PEMDAS. Okay, so parentheses the same as grouping symbols, exponents, multiplication, division, addition, subtraction. Now, are we strict to PEMDAS? I mean, if I draw it up here on the board, you know, that's going to look like P-E-M-D-A-S. Can I switch M and D? Yeah. What is it contingent upon? Okay. As you'll notice up here, it says from left to right. So if division is further to the left than the multiplication, am I going to do division first? Yes. Right? If subtraction is further left than addition, am I going to do subtraction first? All right. So M and D, A and S are interchangeable depending upon left or right location. All right, order of operations. Let's see if there's anything else in here. Okay, like terms. Okay, the terms of an algebraic expression that are separated by addition and subtraction symbols. Like terms have the same variable raised to the same power. They may not have a variable at all. If they don't have a variable at all right, we call them a constant. Constant terms are like terms that always have the same value in the sense that they don't have a variable. Okay, so if I look down here, 5x squared and 3x squared are like terms. I can combine those. Okay, now if that was 5x squared and 3x cubed, could I have combined them? No. So that part up there, they have to have the same variable raised to the same power in order for me to combine them. Combine means to add or subtract their values. Okay? 4 and negative 1 are constant terms. Can I combine 4 and negative 1? Okay, so 4 and negative 1, they don't have to be the same value for me to combine them. They just have to be constants. Notice that they have the same variable raised to the same power in the sense that they each of them have no variable, therefore raised to no power. Does that make any sense? Okay, you guys get that. All right, so we add like terms by adding the coefficients of the terms. Coefficient is the number that occurs in front of the variable, right? What if there is no number in front of a variable? What is there? 1. 1. So if I saw something like x squared plus 4x squared minus 3 y plus 2y, right? How would I solve that? 1x squared plus 4x squared minus 3y plus 2y. So how many x squareds do I have? 5x squared. Okay, and then how many y squareds do I have? Negative 1y. Okay. Now, I don't think that we get into, I'm not sure if we get into it in this lesson, is how we're going to order these things. You're always going to order them, so even if we cover it in a later lesson or cover it in this lesson, I'm not going to write that as negative 1y plus 5x squared. Does anybody know why not? Because in terms of ordering terms in an expression, we want to order things with the variable with the greatest exponent first, and down in descending order until the last thing on my list is a constant, okay, if I have one. Okay, and that's it for that. So what we're going to do now is jump over to answering some questions. If I can find lesson 2. It may already be open up. All right, we got it. And you guys should have this document in your classroom. Okay, something looks like this. Let's see, we are out of here. I'm going to try to follow the same order of things. Let's see. You guys are out of here at 10:36. So I'm going to stop answering questions at 10:26. That way you guys have about 10 minutes to work on your homework. Does that make sense? Okay. All right, so we look at this first question. We've got 9xy minus 8y plus 5x plus 7yx minus 2y. The first thing that I'm going to do, if I'm going to find out what this equals, is I need to combine like terms. Can anybody tell me what terms are like? Let's see, Danielle. Negative 8y and negative 2y. Are there any other like terms? John, you had your hand. He says no. Okay, so that does answer a question. Remember that multiplication is commutative, right? I think we covered that first day of lessons, right? So those x's, that x and y, they can be moved around, right? So effectively they're the same thing. So going based upon that, do I have anything in there that does not have a like term? Diego? The 5x. So this guy's going to be left all alone. So let's go ahead and figure out our correct answer in here. What is 7xy and 9xy? What's that going to be? 16xy. Okay, so far I have an answer here and an answer here that matches up with that. Let's see. I can already probably tell what the right answer is because I know I'm going to be left with 5x. That guy's right there. This guy has no 5x. But just for sake of being able to solve questions without having to have a multiple choice solution, I've got negative 8y and negative 2y. So what should I have? Negative 10y. Okay, that's why I wind up with A as an answer. Okay, good so far? All right, let's clear some things out here. Go to number 2. Evaluate the expression. Simply in this case means to simplify. Let's see, Eric, what would you do with this question? We've got 6 parentheses x minus 6 plus 4 if x equals 8. You plug in 8 at the beginning? Okay, so let's go ahead and rewrite that. We've got 6 parentheses 8 minus 6 plus 4. What's the first thing that you're going to do? Parentheses. 8 minus 6. All right, so what is that? 2. Okay, so we're carrying everything down, right? Okay, Jewel, what would you do after that? We got 6 parentheses 2 close parentheses plus 4. And get 12. 12, bring down the positive 4. 12 plus 4, 16. Okay? All right, so we got that. Very good. So order of operations. You guys, I think, probably started learning order of operations in like the 7th grade, right? Okay, I think I remember whenever I taught 7th grade doing order of operations. So this is by no means anything new for you. You would think that we wouldn't still be covering it, but it still applies. When you learned it in the 7th grade, it was because you were going to be using it for the rest of your mathematical life. All right, let's look at 3 plus 5 into the, I want to make sure that that's right, 5 into the 4th if n equals 3. All right, Axel, what do I want to do with this? So I'm going to write 3 plus what?
5, parentheses, 3, parentheses, 4.
Okay, good. All right, and I really appreciate that you put parentheses around that so that we know that it's, you know, it's not 53. Okay? So with that, what needs to be done first? Okay, so because inside the parentheses I can't do anything with that, your next move is to do exponents, correct? So what's 3 to the 4th? 3 times 3 is 9, times 3 is 27, 27 times 81, 81. So 3 plus 5 times what? 81. Okay, what comes next? What's 5 times 81? 405. So I got 3 plus 405. What's my final answer? 408. Good job. Okay. Okay, we've got about 9 minutes. We'll keep rolling here. Simplify the expression by adding like terms. I tell you what, we've kind of done that. I feel like you guys can do that. So let's move on to something else. I don't want to waste our time with questions we can't answer when there's questions that we might struggle with. All right, number 5, for instance, the number of line segments between n points, basically they're saying, you know, n is representing n number of points, has this formula, 1/2 parentheses n squared minus n. Use the formula to find the number of segments between 7 points. What do I do with that 7, Angeli? Plug it into the n. So we're going to rewrite this as 1/2 times what? Got that?
Yeah. 7 squared minus 7.
Okay, good. What's our next step? The exponent, because it is inside the parentheses, because we would do parentheses first, so we have to simplify the parentheses. So we've got 1/2. What's inside that parentheses then at this point?
41. No.
Remember our?
42.
No.
49.
All right, we want to remember our multiplication or our perfect squares. 49 minus 7, right? What's 49? Now what do I do? Sorry, I'm kind of jumping the gun. All right, 1/2 times what? 42. All right, and 1/2 times 42 is the same as what? Just in terms of mental math. If I'm multiplying something by 1/2, it's the same as dividing it by 2. It's easier for me to think about dividing 42 by 2 than it is to multiply it by 1/2, right? So what's 42 divided by 2? 21. Okay, that way I can do as much of this in my head as I possibly can, because believe it or not, your brain, if it can do math correctly, is faster than your calculator. Okay, depending upon what it is. All right, let's see. So we've got 21 segments is B on that. All right, we have still several questions in here. We're not going to get to all of these. So because of that, what I want you guys to decide is a question that is 6 through, what, 17? Something like that? 6 through, yeah, 17. Give me a question that you want answered. Do you think that, hey, if I was left to myself, I might struggle with this? First person to raise their hand and give it to me. We'll go ahead and start with that. Axel. 15. He wants question number 15 answered. 15. Okay, store is selling the 4 carpets below with their dimensions. What is the total area of the 4 carpets? So in order to find the total area of the 4 carpets, I have to first find the area of each individual carpet, correct? These are all what shape? Rectangles. How do I find the area of a rectangle? Length times width. So what's 2x times 2? 4x. So the first one is 4x. And I'm going to add all these areas together, right? What is the area of the next rectangle? 4x. What's the area of the next rectangle? 3x. What's the area of the last triangle? 2x. 1/2 times 4 is the same as 4 divided by 2 times x, right? So 2x. All right? Are all of those like terms? So I can add their, what? Coefficients. Their coefficients are 4, 4, 3, and 2. What's 4 plus 4? 8 plus 3? 11 plus 2? 13x. And because we don't know anything there, we would say 13x units squared. Does that make sense? Okay, 13x is what they're looking for, but I'm going to be more specific, and we're going to say units squared because they are looking for area. And they don't tell me what the units are. Okay, Jewel, you had your hand up. What question do you want answered? 16? Okay. Kent needs to buy school supplies. Notebooks cost $7x. Bottles of glue, $3x. Packs of markers, $8x. Pens cost $2x. Kent buys 5 notebooks. Okay, so we're taking, this means that 7x means $7 times the number of notebooks that I bought. Does that make sense? So what am I plugging in for x with the notebooks? 5. 7 times 5. Okay? Glue cost $3 per bottle. X is the number of bottles of glue I'm buying. So what am I plugging in for x on glue? Okay, Jewel? How many bottles of glue is she buying? Says down here, Kent, sorry, not she, but Kent, down here. 2. Okay, so 3 times 2. All right. Packs of markers are 8 per. Okay, and we're buying how many packs of markers? 2. Okay, and pens cost $2 per that set, so, or $2 per pen. How many pens is she buying? So we got 2 times 3. We're going to combine all of that. So 7 times 5 is 35 plus 6 plus 16 plus 6. Okay? And we're going, left to right. What's 35 plus 6? 41. And let's go ahead and do 16 plus 6. 22. 41 plus 22. $63. Does that help you out, Jewel? Just kind of take it one step at a time. Let's double check our answer there. $63. All right. We got time for one more question. Somebody else have a question that they want looked at? You think that you would struggle if you had to do it all on your own? Take a quick look. Do we all feel comfortable with like a number 12 or a number 6? You guys feel good about those? Yeah, keep in mind that like on number 12 here, that this is technically, because it's division there, it's under a set of parentheses, or at least this is a set of parentheses. Okay? All right, so we all feel pretty good. We could go ahead and get started on our homework now. All right, we'll go ahead and stop the video here and let you guys get to work.